Okay. One more, yeah, same classified paper. Page 65. Explain what is meant by electromotive force EMF.
Transfer of energy. No.
Electromotive
Electrical
force.
work done.
Each charge. One charge.
Whenever a question is there, anything definition, try to write standard. Don't write definition in your own words, because the definitions are free marks. If you write these in your own words, you may lose, not cover all the points, so you will lose the mark. So it is work done on a unit charge to move around a closed circuit. So how much work we do on a unit charge so it can move around a closed circuit, we call that as electromotive force or EMF.
EMF, right?
Yeah. So work done on a unit charge to move around a closed circuit. Try to memorize this definition as it is a repeated one. I have shared the PDF about all the definitions. The next is an electric heater contains two heating elements R1 and R2. An electric motor operates a fan which blow the cool air over the heating elements. How they're connected? Parallel or series?
Parallel.
How they're connected? Parallel or series?
Parallel.
So they are connected in parallel.
Then how we can pronounce that word?
Parallel.
Parallel, right?
So they are connected in parallel. So what is the characteristic of the parallel circuit? They have the same voltage. If this is 240, this will also be 240 volts. This will also be 240 volts. This will also be 240, because the characteristic of the parallel circuits that they all receive the same voltage. But the current will divide between the branches, and the one which is having a low resistance will have more current. The heater is powered by a main supply with an EMF electromotive force of 240 volts. The switch S1 and S2 are closed now. So we close, when we say in electricity, we close the switch, means the circuit is complete or it allows the current to pass through. The heating element R1 gets hot, and R1 has resistance of R1 is 30 ohm. Calculate the current in the R1. So how to work out the current?
I divided by the formula.
So first thing, yeah. So this is 30 ohm resistance and this is a voltage. So what's the formula? V equals IR.
It's like I equal V.
No, V equals IR, or R is equals to V over I, or I is equals to V over R. Like this is the main structure. V equals IR, the Ohm's law.
We have to write the main structure.
No, if you directly write, let's say you wrote I is equals to V over R, 2 marks are there. One? Two.
One mark.
So just
1 mark for the correct answer.
so 240 divided by 30. What's the answer?
8.0.
So 24 divided by 3, that will be 8 ampere.
Actually, it was 8.0. In calculator.
Yeah.
8.
8.0.
Calculator, look.
Then calculate the power. How to know the power? The power is having 3 different formulas.
P equals to
P equals VI,
I square R.
P is equals to I square R, and P is equals to V square over R. Because we have all the parameters. We have voltage, current, and resistance. So we can use any of them. Like we can use the first one, we can use the second one, or we can use the third one. All will give the same result. You have to memorize all these formulas. So the voltage is 240 and the current is 8. So 240 multiplied by 8. What's the answer?
1900. 1920.
1920, and the unit is what?
Actually, I copied right.
No, marking scheme answers are rounded off answers. So you will write 1000, or you can write 1.9 exponent. No, it's fine. It's fine. 1.9, it was 1.9 exponent 3. Then the resistance of the heating element R2 is 60. The switch S1, S2, and S3 are closed. State and explain how the current of R2 compare with R1. But you have to compare. Look, this is 30 ohm and this one is 60 ohm. So if I compare the current in these two, which one will have a high current? The low resistance, R1 will have a high current because it is having a low resistance. And R2 is having a less current because it is having a high resistance. And what is the comparison of the current? The comparison of the current depends on the ratio of the resistance. Because if you compare the ratio of the resistance is 1:2. It's not necessary, but you can see the figure that one resistor is 30 ohm, another one is 60 ohm. So if I compare the current is always inverse of resistance. So if the ratio of the resistance is 1:2, what will the ratio of the current? 2:1 means the current in R1 will be twice as compared to current in R2. So whenever two resistors are connected in parallel, the current will divide. If they have the same resistance, then the current will divide evenly. But if they have different resistance, the one which is having a low resistance will have a high current, and the one with a high resistance will have low current. So in this case, when we compare, we'll say the current in R1 will be greater than current in R2. And then what is the comparison? We'll say the current in R1 will be twice as compared to current in R2. But what if this was the question? This is 30 ohm and this one is 90 ohm. Now which one will have a high current? So this will have, again, it will have a high current R1. But what is the comparison?
Three times.
3, because the ratio of the resistance is 1:3. So ratio of the current will be 3:1, opposite. So means the current will be 3 times in R1 as compared to that of R2. So whenever components are connected in parallel, the one with the low resistance will have a high current. And it's a comparison in physics. Whenever there is a comparison, always, or even in chemistry, if there's a comparison, always try to write the values in ratio. When you compare something, it's a ratio actually. Okay, like twice, thrice, 1.5 times, 3 times. It can be decimal as well, the ratio, but the simplest ratio is always in a whole number. But you can also say like 1.5 times, 2.5 times. That's also fine. So first thing we'll mention the current in R1. Then R2, and then the current in
We
R1
can use double word, right?
is twice. Yeah, yes, you can use the word compared to R2.
As the resistance of
The ratio of the current is 2:1 between R1 and R2. No, if you write like example, the current in R2 is twice as compared to R1. Current in R1 is twice as compared to R2. So you will score both marks. Because you already mentioned, yes?
Current will be greater than R2 because the resistance in R2 is
Yeah, the
more than
comparison.
R.
Yeah.
Okay. That will still score us
Will be
two.
less than R2. Double the.
R1 is more, R2 is less. The current in the motor is 0.1 ampere. The cable for electrical heater to plug from the main socket is safe when the current is less than 20. Suggest and explain suitable fuse rating. The current in the motor is 0.1. What was the current here? Look, the current, the current here is 0.1. Okay. What was the current here? 8. What should be the current here? No.
Double.
Half.
Yeah.
Because this is 30 ohm, this is 60 ohm, according to question. So the current here should be half of. The ratio should be 2:1 for the current.
It should be more.
So what is the total current in the circuit?
Actually, 240, right?
Current, not voltage. Current. 8 ampere here, 4 ampere here,
12.30.
12.1. So what should be the fuse rating? I should select a fuse. So we can say the current in the circuit is, the total current in the circuit is 12.1. So you can say that 13 ampere fuse is suitable for this circuit.
So it's in 12.5.
So we will add fuse from both sides, or?
No. Fuse only one component is connected. Then a diode will be there. This is not connected to like shown, but there will be diode as well before the components. So the total current, the fuse rating, you can select like 13, 14, 15. How we know that the current is given in the question. This current in the motor is given in the question that this current is 0.1 ampere. Okay. And they mention here the main socket is safe when the current is less than 20. So first we work out what is the total current. So if the current here was 0.1 ampere, current we calculated it was 8 ampere. And current, how we know about this one? Because this has a double resistance, so half current 4 ampere. So the total current we work out should be 12.1 ampere. So if the total current is 12.1, we should select a fuse with a rating of motor.
12.5.
Near the R1.
Which one?
Near the, what is that written R1?
R1 is 30 ohm, 30.
That's 30.
30 ohm, 60 ohm. Like this is a 30 ohm resistor, this is a 60 ohm, and here motor is having 0.1. So the total current is 12.1. So we select a fuse more than 12.1. Fuse is always according to the maximum current in the circuit. Like we check what is the maximum current in the circuit, and then the fuse we select accordingly.
Sir,
Yes.
is there a 12.5 fuse?
Whole numbers are there, like 13 ampere fuse. If you see 13, 14, 15 is written, it's not like 0.5 fuse is there. This question is related to electromagnetic effects. This is an electric starter motor is there in a car, switch on and off using a relay. Relay is an electromagnetic switch. Like when the current passes, it produces a magnetic field. When
Not in the service anymore.
No, relay is the application of magnetism. It's not specifically a topic, like detailed topic, but it's an application. Like they can ask about relay. So when you close the switch, look, when you close the switch, the current start to flow, okay? The current will flow through this solenoid.
So what is
So
the
it's,
design?
Solenoid means a coiled circular wire is called a solenoid.
Sir, why it is, sir?
So that it will produce a strong magnetic field. That's why it is coiled. So when a current is passing through this solenoid, it produces a magnetic field. When it produces a magnetic field, these are the strips. You can see made up of iron, stringly iron strips are there. So when the current passes, it's not like current is passing through it. The current is passing around it, which produces a magnetic field. And because of the magnetic field, these two strips of the iron behave like a magnet, and they will come in contact, like it's close. So if I draw this, this is a magnetizing coil, okay? And in the magnetizing coil, two strips are there made up of iron. So when the current passes through the magnetizing coil, it produces a magnetic field. These pieces of the iron behave like a magnet. When they behave like a magnet, they attract each other, move towards each other. When they move towards each other, so if we connect anything to this part of the circuit, that will start to work. But that also need electricity. So we have to provide electricity, like another battery, or we can use the same battery to provide. That is another question also in the same. But this is a working principle. Like when a current is passing, it produces a magnetic field and close these magnetizing like iron strips. Figure 7.2 shows the equipment from figure 7.1 inside a magnetizing coil. The magnetizing coil is in series with a 12-volt battery and switch S, which is open. Switch S is now closed. Explain what happened to the springy iron strips X and Y. What will happen when we close the switch?
Join together. They'll join.
So when we close the switch, a current passes to a circuit which produce magnetic field. And yes, yeah. When we close the switch, a current will pass through this circuit. When the current passes through the circuit, it produces a magnetic field which magnetizes the springy iron strip and come in contact with each other.
So why do the comment for that?
Because the opposite pole will be induced. How opposite pole will induce? Like example, this will be north pole, this will be south pole, this will be north pole, this will be south
So
pole.
what do you call that act?
Induced magnetism.
Induced.
When we magnetize an object by another magnetic field, either by a current, we call induced magnetism. So it's of 3 marks. How to score the 3 marks? Yeah, the current passing through the. But you have to write as well, even the way you said, but you have to write.
करना चाहिए सर एग्जामिनर को लिखवाना चाहिए उस बोल के क्या नाम है एग्जाम करना चाहिए
The current passes through a wire, produces a magnetic field.
सर क्या लिखना जरूरी है? सारे बच्चे
Which- What?
produces a varying or
No, not varying. It's a constant because a DC supply is there.
बस मैं ही लिख रहा हूँ.
The current passing through a wire produces a magnetic field which magnetize the battery is DC,
the AC
which magnetize the springy contact.
थोड़ा सा cheat करते हैं
By generator, you produce that.
नहीं लिखा होता है AC जनरेटर के ऊपर कि कौन सी चीज से उसको करंट आ रहा है बस ये लिखा होता है AC पावर ट्रांसफार्मर तो बड़े मजे थे यार
Transformer questions are relatively easy questions.
सर अच्छे तो होते हैं मैं ही लिख रहा हूँ बस.
Write in your own words.
सर बस आखिरी दो लफ्ज.
The current passes through a wire, produces a magnetic field which magnetizes springy contact and induce magnetism. So X and Y will come in contact. The next is the power of the starter motor is 1.8 kilowatt and it is operated by the car battery. State the current in the starter motor. We know the voltage of a starter motor. What is the voltage? 12. And we know the power.
1.8.
So P is equals to VI.
Formula P is
We will just multiply.
P is equals to IV or VI. It's the same thing. Order is not because it's a multiplication. So order does not matter. 1.8 kilowatt. How much in watt? So 1800 watts.
1008.
volts.
So 1800. Voltage is 12 and the current we don't know.
We will divide it.
1800 divided by 12. What's the answer?
18 volts.
Ampere. It should be.
Ampere. How?
150? Okay.
1800 divided by
12.
150.
150.
15. 15. 1 5.
15. 1800 divided by 12.
150.
150, okay. 150 is the answer.
Sir, how?
There are 180.
1800.
1800 divided by
Sir,
12.
say the number correctly, sir.
I said 1800.
1800, sir. This is not the
1800 means 1800.
Sir, then how much is 1900?
1900.
Yeah.
The starter motor, yes.
मिली का यूनिट कैसे like क्या difference
If it is a milli, then small m is written. If it's a micro, then this symbol is there.
micro
Mega.
Micro. Micro means like divided 10 raised to power minus 6. Milli means 10 raised to power negative 3.
so बताओ mega
Mega is capital M.
that's also a capital
Small m.
micro
Micro is not M. Micro is a Greek alphabet. Mu. The starter motor circuit is connected between the terminal W and Z. Explain why copper wires with a large cross-section area are used. If I increase the area, what is the relation between area and resistance?
resistance will decrease
So if area is more, the resistance will be less. And the second thing, it is 150 ampere, so means it's a high current. Okay, large current is there. For a large current, we want thick wires. Thin wires cannot carry a large current. It will produce a lot of heat energy.
So the wire will burn.
Because wire will melt even because of the heat energy. That's why, like example, if you find a wire which is connected to air condition, it's much thicker as compared to wire which is connected to a charger. Because the charger is like this charger is not carrying too much current, but the air condition or a heater which carry a large current, so we need a thick wires for that. It's in ampere, like example 0.3, 0.7, very low.
Is so thick than the
Yes, sir.
No, because HDMI cable is carrying information, like its ports are there, which is yes, it is carrying information, data, like transferring a data, greater amount of data in a short time. That's why it is using a large cross-sectional area. It's not about the current.
इसका मतलब सर जो जाहिल है उनका वो छोटे
Okay, so why copper wire with a large cross-sectional area is used? So large cross-sectional area will have low resistance. Minimize the heating.
how many for you? Or I have zero at this. Actually, I have
सर अगर जरूरी है लेकिन मेरे से बात हो गई लिख ही नहीं रहा
No space between them.
Okay, the next figure, last question. Figure 7.3 shows a relay and a symbol of a battery. Complete the circuit. We want to connect a starter motor.
Sir, with what?
Yeah, look, figure 7.1 shows a relay and the symbol for the car battery and the starter motor. Okay, this is starter motor. The springy iron strips X and Y act as a switch. We want X and Y to be a switch. Okay.
So we connected to Z.
Then complete the circuit diagram for the motor.
The one
For
we connected to the car battery.
okay,
And one we connected to Z.
very good.
बिल्कुल opposite आपने बताया.
No, it's a like
मेरा मतलब था सर इसको या direct क्यों नहीं connect किया?
No.
क्यों कर दिया?
First thing what we want it to be a switch.
Yes sir. तो ये
So when look first thing we want it to be a switch. So when we close this switch, it will produce a magnetic field. When it produces a magnetic field, this will come in contact.
Yes sir.
When this will come in contact, now this circuit is closed. Okay, that is the first thing. Because we want it to use as a switch. When we close the switch, the starter motor, the induction motor is there. That this due to a magnetic field, the switch will close, and the circuit will be complete. Second thing is supplying the electricity, the power to the motor. How to connect the motor? Like we also want a motor to work as well, because motor is not having any supply. The starter motor.
So connected to a
plug-in.
Starter motor is not no starter motor. We also want a starter motor to work.
सर मैंने
Sir,
सीधा
bring the wire.
सर नहीं like सर अगर हम लोग इसको यहाँ
Or even if I connect, look, this is one way. Or if I connect here,
Sir, there is two ways to connect it, either by the car battery or from ZNW.
no. This connection is there. This has to be connected like this, so that the switch. Now I want to connect a battery. What I should do?
XNS.
Where I should connect?
Sir, that thing, I don't know what it's called.
relay.
Sir, you know what I mean? This one.
This takes something.
Yeah,
Sir, close it.
this switch.
Yes, the switch.
No, when we close the switch, this will come in contact. The switch is closed. Okay, but now I want to connect a starter motor. I want to supply electricity. No, not transformers. The same circuit. What I should do?
Open it.
You can annotate on the screen for the online session.
The switch.
Look, we have a starter motor.
Okay.
When we close this switch, it produces a magnetic field and it close
तो सर
This part.
current नहीं जाएगा।
Now we connected a motor here so that the motor will work. Okay. But the thing is, we also want to connect a battery. We want to supply electricity to the
Sir,
motor
coil-
as well.
coil लगा दीजिए।
What I should do?
We can
We
connect
put a
the
coil
ground.
on the
Actually,
circuit.
why mistakes here?
Hmm.
Sir, coil
No,
लगा
no,
दीजिए।
no additional thing.
No
What?
additional.
No additional thing. Where I should connect?
Connect W and Y together.
Good.
सर आधे घंटे से मैं ये शुरू पिघला इस क्वेश्चन से पहले ही मैंने बोल दिया
Okay.
उसके
So,
साथ
The main idea is that because what we want this circuit to work when there's this springly contact, the springy contact is there. So when we connect, close the switch, the current will pass through. This will come in contact, and then the current is passing through Z through the motor and then going back into the battery.
But how, sir, we have to
So
make the
if you open the switch, then there's no magnetic, like induced current here, there's no magnetic field. So this will lose the contact and the motor will be off. So that is how you should connect.
ये पहली बात है।